So I'm going to walk you through my multimodal rack system. So let me start with the high level architecture that we see on the screen right now. So this system handles three kinds of inputs, which is PDFs, audio files, images, and yeah, tables, etc. in the documents that we upload. And starting with the pre-processing pipeline, it has four key components, as you can see here. Document processing uses unstructured.io for intelligent PDF parsing, and then audio processing uses Whisper ASR with chunking for long form content, and image processing leverages the LLaVA 7B for vision understanding, and LLM analysis provides summarization using 7B parameter model. So everything runs on GPU acceleration. I use Colab for this. Coming to the vector storage architecture, for storage, I use separate ChromaDB instances for documents and audio to prevent cross-contamination. I chose BGE because it's currently top performing on MTEB benchmarks for semantic similarity tasks. Coming to the fine-tuning component, the fine-tuning pipeline generates business-focused Q&A datasets from the document content and uses T5 small with LoRa rank adaptation for parameter efficient training. But to be honest, you can use anything. You can use T5 large or any better model. I use this because of GPU constraint. And I believe that in practice, prompt engineering often outperforms fine-tuning smaller models with today's powerful base models. Coming to the conversational interface, it's pretty straightforward that we have four interfaces, separate for document, audio, and fine-tuning and smart caching. And for production, this is complete Flask API with REST endpoints. We'll look at it later. Now let me show the actual system in action. I'll demonstrate the document processing and the multimodal capabilities. I already uploaded a document. It's the famous paper. The 2017 attention is all you need. Transformers paper. It's already processed and you can see the status over here. Let me start querying this document. Let me shoot what does attention mean mathematically. It's gonna take a couple of seconds. In the meanwhile, we can process an audio. I'm processing a Greek. It's not in Greek, it's about a Greek book. So, yeah, you get the response. It refers to the mechanism that focuses on different things, weighted sum of the input sequence. Yeah, so let me ask an query on the image. So, explain clearly about the transformers architecture. That's loading. A couple of seconds again. So as you can see, it's designed for sequential data. The key component is self-attention mechanism. And yeah, that's about it. We have an encoder and a decoder. This is how it works. Now, if I ask the same question again, let me see how it responds. Yep, it's retrieved from the document cache. Coming to the audio processing part, I'm processing this audio. It's going to take a couple of seconds again. Now, locally, I already pre-processed like a bunch of documents. There's a resume, there's my resume, there's a job description, and a few other documents and three audios. So, locally, I used Mistral because Lava was taking a lot of inference time and the latency was very high. I basically activated my Conda environment. I had all the requirements in it. I installed all of them and I ran the Python application. The same thing, I have a set of documents here which I can query. I queried about a job description. I got the appropriate responses. And the audio chat, I can choose anything from here. But suppose, let's say I'm using the Greek one again. Let's see how it's different from how the responses are different with Mistral and Lava. What is audio about? Since I'm running this locally, I use Mistral, but over here I used Lava. Let's query it. So what is the audio about? Couple of seconds more. Coming back here, we get the response from Mistral. Let's ask who's the speaker. Going back to our Gradio interface, we get the response asking the same question, who's the speaker? Nothing to demonstrate here, but just the capabilities of Lava and Mistral. The architecture is pretty much ready with proper error handling and monitoring and also scalability considerations. The key insight is that modern Gen AI engineering is about combining the right tools, powerful base models, and sophisticated prompting and efficient retrieval and robust infrastructure. So rather than just fine tuning, that's about it. Thank you.